In this lecture of Laplace transform, let us consider the function f of t, which is divided by t. So what happens? It basically leads to integration of the Laplace transform. Now what does this mean? Now if the Laplace transform of f of t equals f of s, then the Laplace transform of the given function f of t, if f of t is divided by t, then the Laplace transform of this entire function would be f of s integrated within the limits s to infinity ds. So let us prove this. So proof. So we know that Laplace transform of f of t is nothing but f of s, which is equal to 0 to infinity e power minus st f of t dt. So now let us integrate with respect to s within the limits s to infinity on both the sides. So you have integral s to infinity f of s ds equals integral s to infinity, and then you have integral 0 to infinity e power minus st f of t dt ds. Right? So now interchanging the integral, so you have 0 to infinity s to infinity e power minus st f of t ds dt. Right? So of course f of t, there is no s here, so it is almost regarded as a constant. Now I integrate e power minus st with respect to dA, with respect to s. So you have 0 to infinity integral e power minus st is e power minus st divided by, so we are integrating with respect to s, so divided by minus t within the limits s to infinity. Then of course you have f of t dt. So what happens here? So we have integral 0 to infinity, let me take minus 1 by t common, so you have e power minus infinity minus e power minus st, because here in the first case s is replaced by infinity, so it becomes e power minus infinity. The lower limit s is replaced by s itself, so it is e power minus s f of t dt. So this of course is 0, minus into minus is plus, so you get 0 to infinity e power minus st f of t by t dt. So this is nothing but Laplace transform of f of t by t. And here the LHS is nothing but s to infinity f of s ds. So therefore the Laplace transform of f of t by t is nothing but integrating f of s with respect to s within the limits s to infinity. So let us take a few examples. So first example, find the Laplace transform of e power minus at minus e power minus bt divided by t. Now according to the expression, if the given function f of t is divided by t, then find f of s and then integrate it within the limits s to infinity. So consider the numerator as f of t. So find the Laplace transform of e power minus at minus e power minus bt. So which is nothing but, so here e power minus at, you know that Laplace transform of e power at is 1 by s minus a. So since you have minus a, it is 1 by s plus a minus 1 by s plus b. Now Laplace transform of e power minus at minus e power minus bt by t is nothing but taking the integral s to infinity. So this is f of s. So I have to integrate this, right, from s to infinity f of s, which is s 1 by s plus a minus 1 by s plus b ds. So you know that integral of 1 by s plus a is log s plus a minus log s plus b within the limits s to infinity. So this is log of s plus a divided by s plus b with the limits s to infinity. So here I cannot substitute s equal to infinity directly. So what do? So we get log 1 plus a by s divided by 1 plus b by s within the limits s and infinity. So now when I put first s equal to infinity, a by infinity is 0, b by infinity is 0. So we get log 1 minus log, I replace s by s itself. So it's going to be log of s plus a divided by s plus b. Again, if I take the LCM. So log 1 is 0, so which is minus log s plus a divided by s plus b, or it is log s plus b divided by s plus a. Example 2. Find the Laplace transform of sine 2t by t. So again, first find the Laplace transform of sine 2t. So here a is 2, so therefore sine at Laplace transform is a divided by s square plus a square. So it's going to be 2 divided by s square plus 4 or 2 square. So now to find the Laplace transform of sine 2t by t. Now this is f of s, so this has to be integrated. So integrate s to infinity, 2 divided by s square plus 2 square ds. So we know that integral a divided by x square plus a square is tan inverse x by a. So here a is 2 and instead of x we have s. So this is going to be tan inverse s by 2 with the limits s to infinity. So first put s equal to infinity. So you get tan inverse infinity minus tan inverse s by 2. So tan inverse infinity is pi by 2 minus tan inverse s by 2. So pi by 2 minus tan inverse s by 2 is cot inverse s by 2. So therefore Laplace transform of sine 2t by t is cot inverse s by 2. So find the Laplace transform of cos at minus cos bt divided by t. So again first consider the numerator. So we have to find the Laplace transform of cos at minus cos bt. So we know that the Laplace transform of cos at is s by s square plus a square. So this is going to be s divided by s square plus a square minus s divided by s square plus b square, and this is f of s because we are considering this as f of t. So now what is Laplace transform of this entire thing? Cos at minus cos bt divided by t, it is nothing but s to infinity f of s, which is s divided by s square plus a square minus s divided by s square plus b square ds. Right? So this is nothing but log s square plus a square into 1 by 2. So if I differentiate this log s square plus a square, I get 1 by s square plus a square into 2s, but I do not have 2 here, so multiply this expression log with 1 by 2 minus again half log s square plus b square, of course within the limits s to infinity. So I can take 1 by 2 common, and then you have log of, so this is of the form log m minus log n, which is log m by n. So s square plus a square divided by s square plus b square with the limits s to infinity, which is 1 by 2. Again divide numerator and denominator by s square because I cannot substitute s square directly. I cannot make s square equal to infinity. So now log 1 plus a square by s square divided by 1 plus b square by s square with the limits s to infinity. So now when I put s equal to infinity, I get log 1 because this becomes 0, this also becomes 0. So you get log 1 minus log, again put s equal to s, so you get the same term, right? So ultimately you would get the same expression, s square plus a square divided by s square plus b square. So what is log 1? It is 0. So it is half into minus s square plus a square divided by a square plus b square. So to remove the negative sign, I can take its reciprocal. So you got a square plus b square by a square plus a square into 1 by 2. So this is the answer. So therefore, the Laplace transform of cos AT minus cos BT divided by t equals 1 by 2 into log a square plus b square divided by a square plus a square. So example 4, we have e power minus 2t into sine 2t into cos hyperbolic t divided by t. Now before I proceed, do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And you can also join the Telegram group for engineering mathematics. The link has been given in the description. So now observe, you have e power minus 2t. So we have to use this expression, the first shifting theorem, and you have cos hyperbolic t into sine 2t. So when you have sine and a hyperbolic function multiplied together, the hyperbolic function cos hyperbolic t has to be expressed as an exponential. So now let me consider these two. So you have sine 2t and cos hyperbolic t can be written as e power t plus e power minus t by 2. And this is multiplied with e power minus 2t, right? So now I have only considered the numerator. So we are just considering the numerator as usual. So this becomes equal to f of t now. So now multiply e power t and e power minus 2t. So we get e power minus t, right, into sine 2t, half is common, plus e power minus 2t into e power minus t is e power minus 3t sine 2t. So now to make things easier, let me first consider sine 2t. So Laplace transform of sine 2t is 2 divided by s square plus 2 square. Now I consider, because I have t, that means you have the entire expression f of t divided by t, isn't it? So let me consider sine 2t by t, which is integral s to infinity ds. So now we know that this is of the form a divided by x square plus a square integral, which is nothing but tan inverse s by 2 within the limits s to infinity. So you have tan inverse infinity minus tan inverse s by 2. So you get pi by 2 minus tan inverse s by 2, and this is equal to cot inverse s by 2. We have already done this in the previous problem. So you have cot inverse s by 2. So this expression is cot inverse s by 2. So now we have 1 by 2 Laplace transform of e power minus t into sine 2t by t plus e power minus 3t sine 2t by t. So we have already found out the Laplace transform of sine 2t by t, which is cot inverse s by 2. So when you have the given function multiplied with an exponential, then you have to translate s by a. So here a is positive, so it is s minus a. Here a is negative, so it's going to be s plus a. So here in this case we have 1 by 2, right? So you have cot inverse s by 2. So for the first case a is minus 1. So you're going to replace s by s plus 1 plus cot inverse s by 2. Replace s by s plus 3. So we get 1 by 2 cot inverse s plus 1 by 2 plus cot inverse s plus 3 by 2. So this is the Laplace transform of this entire expression, right? So usually we consider the numerator as f of t, but to simplify the process, what we do is you represent cos hyperbolic t as an exponential, and first find the Laplace transform of sine 2t, and then find the Laplace transform of sine 2t by t, which gives me the answer cot inverse s by 2. So now this entire function is multiplied with an exponential. So here I'm going to use the first shifting theorem, wherein wherever s is there, you are going to translate s by s plus a or minus a depending on the value of a. So here a is minus 1, so it's going to be s plus 1. Here a is minus 3, so s is going to be s plus 3. So wherever s is there, substitute s as s plus 1 in the first expression. Wherever s is there, substitute s by s plus 3 in the second expression, and we get the final answer. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.